Okay. Hello, everybody. My name is Marcos Zivaridis. I would also like to welcome you all to our first webinar. I'm very happy to meet you all. And I hope that these webinars fully meet your expectations. I work as a pre-sales engineer at a full-time job at a robotics company. But my hobby was 3D printing, so on top of that, I registered in the Enable Greece team. And now I am your tutor. So, without further ado, I will share my screen and let's start the presentation. Okay. Is everything okay, Thanos? Wait, let me change that. Okay, I think we are fine, right?
No, we still can't see your screen.
Okay, let me reshare it.
Yes.
That should be fine.
Yeah.
Let me hide that. Okay. So, we are going to do the basics of 3D printing. We are going to examine some basic information regarding 3D printing, and we are going to see some 3D printing objects that are printed in various fields, from amateur stuff to more professional ones. And let's go and see some content so you have an overall idea. Specifically, we are going to examine the 3D printing technology, and we are going to define how it works. What are the different methods of 3D printing? What are the different materials we can use? And together we are going to decide which method and material are going to be used for a beginner in order for them to be easy to start a new project. Finally, we're going to see some 3D printing applications and talk about the future of 3D printing and how you can start your own business. So I will try to give you some ideas, in my opinion, of how you could start from simple steps to scale to a business model. Okay, so let's start with the interesting stuff now. So up until now, the industry was using several methods for creating custom products, but those had some specific restrictions. As you can see, the first method is the formative manufacturing, which makes use of stress like compression, tension, shear, which causes the plastic deformation of a material into a desired shape. The manufacturing process is typically for plastics and metals, like the plastic bottles you drink from every day, for example. This process, of course, it is easy. You simply add liquid material inside the mold and it becomes solid. The way you can produce the same object over and over again is just to simply add liquid and subtract it again. So what is the disadvantage about this process? Basically, the mold, if you want to redesign the model, the mold should be recreated and the final object, so that the final object will be recreated. So this takes a lot of time since the mold is not easy to create. The second method is the subtractive manufacturing, which is an umbrella term for various controlled machines and material removal processes that start with solid blocks like bars cubes, rods, other materials that are shaped by removing material through cutting, boring, drilling, and grinding. The disadvantage of this process is that, of course, a lot of material is being wasted by chipping away some of the material that we used in order to produce our last object. And now we come to the additive manufacturing, which is basically the technology that we use in 3D printing. In the additive process, an object is created by laying down successive layers of material until the object is created. In this way, no extra material is used. And if something seems wrong halfway, for example, we can stop the printing and save a lot of time and material. Oh, sorry. Okay, there we are. So, let's talk about the 3D printing process here. Before the use of additive manufacturing, there is a specific path that we should follow in order to 3D print an object. First, the object should be created in a digital form. It could be an object we design in our computer, a 3D scanned object, or a photo scanned object. The data of the desired object will be converted into an STL file, and then the file will be sliced by a specific program called the slicer. And we will talk about it in the third webinar. So it can be, this program is called the slicer, as I said, and it divides the 3D model into little geometrical pieces. Finally, the slicer creates a G-code file with the information of those pieces, let's say. And this file will be inserted to the 3D printer, and finally, we can start printing the object. So, the revolution is not additive manufacturing, it is the ability to turn data into things and things into data. And in other words, what Mr. Gersenfield says is that we can think of an object, design it, and make it real in a few hours with 3D printing. It could be just a spare part we cannot find in the market, or maybe it's taking forever to arrive from the vendor. Or it is something completely original and innovative we want to create from scratch. On the other hand, if we want something to be changed in an existing object, we can 3D scan it, make the corrections we desire, and print a whole new object. Okay, the benefits of 3D printing. First of all, speed. I think I talked about it before. Comparing with the other manufacturing technologies, 3D printing is the fastest one, even for more complicated designs. The second one is the cost. So if we just need one piece of an object, 3D printing is the cheapest way to produce it. Even if you need to print the object more than one times in a trial and error mode, it is still the cheapest because you change it again and again and again, but still you create one object. The rest of the manufacturing technologies become competitive if you need mass production of an object. The third one is risk mitigation. So as I said, the trial and error method means that small changes could be mandatory for an object to perfectly fit in a place. Complexity and design freedom, as you can see in the picture, we can print whatever you imagine, as complex as it can be with no restrictions actually. Well, there are some restrictions, but we can overcome those restrictions with easy to use tools. And the fifth one is customization and ease of access. Which means that everyone can have a 3D printer and print whatever they want and as many objects as they need until they create the one that is perfect for their job with so little money that you can't do with subtractive manufacturing. For example, you need a 10,000 euros CNC machine in order to create a small part. Question. How many 3D printing technologies do you know? Additive manufacturing can be applied in more ways than one. So you can give me a number in the chat. I'll wait for a minute. Just a number, just a guess, let's say, of what do you think? A number of additive manufacturing technologies there is there outside. Any answer? No one? Ah, okay, 0, 1, 0. Wait, 2. Okay, I don't know why so many people say 0. That's weird because 3D printing is an umbrella term for a lot of technologies. 1, 1. Oh, it's how many we know. Okay, okay. Yes, that's the question.
Okay, that makes sense now.
Okay, okay. I said how many they exist. Okay, so okay, that's fine. That's fine. So let's stick to that question. So most of you know one method, and I think this is the FDM method. And if some of you say 2, I guess it's something like the SLA method, because this is the second one that most people tend to use and see. All right, so I will move on to see those methods together. As you can see, there are numerous 3D printing technologies, and of course, no one can use all of them. We are going to see in the upcoming slides the 3 most popular 3D printing methods. 2 of them are considered more home-friendly methods, so you can use it. You can actually buy a 3D printer and use those methods in order to print. And the last one is the most popular industrial right now. So you can have a look of how industrial 3D printing happens. Let's move to the first one. The first one is the FDM 3D printing, and I think this is the one that most of you thought about when I asked you this question. So, as I said, the FDM 3D printing is a home 3D printing method. The way it works is that a spool of thermoplastic filament is first loaded in the printer, like you see here. Once the nozzle has reached the desired temperature here, this is the nozzle, the filament is fed to the extrusion head and in the nozzle where it melts. The extrusion head is attached to a 3-axis system that allows it to move in the X, Y, and Z direction. You can see that here. And the melted material is extruded in thin strands, and it is deposited layer by layer while it cools and solidifies. So let's say that these are the layers, and this part here is already solidified because it cools with the use of normal temperatures. Sometimes the cooling of the material is accelerated through the use of cooling fans. You will see the cooling fans in the video after this. And of course, to fill an area, multiple passes are required. For example, similar to coloring a rectangle, when a kid colors with a marker, let's say, on a drawing book. This is the same way that a 3D printer creates a layer. Okay, so this is where I should stop and share the video. All right.
Thanos, is there anyone in the meeting, in the waiting room?
What? Thanos?
No, I can't see anyone, any other person in the meeting room.
Okay. Let me start the video then.
Okay, Marcos.
So here you can see how an FDM printer works. As I said, it goes layer by layer. And the moment the filament comes out, it becomes solid because of the normal temperature inside your house, let's say. And it prints layer by layer. Now you can see it design a ring. And this is it. Simple, I think. Okay. Now let me, sorry guys for that, but I will have to stop and reshare every time we try to show you a video because there is a problem with Zoom in order for you to see the video in better quality.
Okay. It's okay, Marco. Don't worry.
There we are. So, what can we print with FDM printers? We can print everyday objects, as I said, gadgets, tools, like the can opener you see, spare parts, anything plastic generally. And depending on the material used, you can print anything you can imagine, guys. So, as I said, there are no restrictions in the design. What I would say is that the restrictions are on the material type. For example, you can not use the FDM method to print 100% metals. But there are some types of filament that have 80% metals. We will discuss about it in the end of this presentation. Okay. Now, the second type of 3D printing that I wanted to talk about is stereolithography. Stereolithography is a form of 3D printing technology used for creating models, prototypes, patterns. Thanos, can you mute the participants? Thank you. So, as I said, stereolithography, or else SLA, is a form of 3D printing when you print layer by layer using photochemical processes by which light causes chemical monomers to link together and form polymers. Those polymers then make the body of a three-dimensional solid, and this is how you create actually your model. DLP is a similar process to stereolithography, and in that it is a 3D printing process that works with photopolymers. But the major difference here is that the light source DLP uses is more conventional light source, such as an arc lamp, for example, with a liquid crystal display panel, which is applied to the entire surface of the vat of photopolymer resin in a single pass, which makes it faster than SLA. Also, like SLA, DLP produces highly accurate parts with excellent resolution, but its similarities also include the same requirements for support structures and post-curing. However, one disadvantage of SLA is that DLP uses only a shallow vat of resin to facilitate the process, which means that basically you use much less material when you use the DLP method. Now, the third one I would like to talk about, the one they call here MSLA, is the LCD 3D printing. That's how most of people call it. And this is nearly the same as DLP, but it also flashes completely layers at the resin tank, but with the UV light coming from an array of LED shining through an LCD, not a projector. So since I'm pretty sure that some of you didn't understand anything of what I just said, and this is fine, guys, because this is an introduction to 3D printing, not a masterclass. And in order for you to understand how it works, it's better to show you a video because, to be honest, the first time I saw that, I also didn't understand anything of those. So in order for you to have a better understanding, I've also added a video here. Okay, resharing. That's okay.
DLP, laser, and LCD are the three main technology types for desktop 3D printing in dentistry. To understand how they work, we need to know something about how 3D printers see 3D models. When you send a 3D model to your printer, the software slices it into hundreds of two-dimensional layers. Your printer sees a print as hundreds or thousands of these image layers that it will print one on top of the other until the model is complete. The chemistry of 3D printing resins means that each printed layer sticks to the build platform, but not to the resin tank. Once a layer is complete, the build platform lifts slightly and then a new layer is drawn atop the previous. This process repeats over and over until eventually the models are completely built. Although DLP, laser, and LCD all follow the same basic process, they differ in how they deliver light to the photopolymer resin, and this divergence makes all the difference. Let's take a closer look. DLP printers use a light projector, similar to what you would find in a movie theater, to project the image of an entire layer simultaneously, regardless of the number of parts. Because they carry a full layer in a single flash, DLP printers can be outstandingly fast. They are also very reliable with low complexity and no moving parts. SprintRay Pro is powered by a DLP projector of our own design, enabling it to 3D print models quickly and with outstanding accuracy. LCD printers use a screen, similar to the one on your smartphone, to project the image of an entire layer at once. In this way, LCD printers are quite similar to DLP. They can even share materials. But LCD panels have a few key drawbacks. The light used to cure resin is damaging to the organic compounds in LCD screens. Therefore, most LCD printers treat their light source as a consumable, requiring frequent, costly replacement. Laser printers use a pin dot of high-intensity light to draw each layer. This process is similar to using a fine-tipped pencil to draw on paper. The laser rapidly moves across the resin tank, drawing the details of each layer as it goes. The laser must fill in the entire area with a pin dot of light, which limits the speed of the printer, especially when printing multiple parts at once. DLP, laser, and LCD printers are all used in dentistry, but the speed, simplicity, and durability of DLP has made it the first choice of dental professionals all over the world. Interested in learning more? Come visit us.
All right. Oops. Let me check here. So I hope you had, okay, I have to go past all of this. I hope you had a better understanding here of how the SLA method works. So what can we print here, guys? Basically, in comparison with the FDM technology, we can print the same stuff. The major difference here, as you can see in the pictures, is that you can have more detailed objects with better accuracy and a far more appealing look at the final product. So in case you want to have a professional look, let's say, on your models, SLA is the way to go. The third type is the powder bed fusion method. The one that as I said, is used in industrial 3D printing. So the way it works is that a laser or an electron beam melts and fuses the material powder together. So all powder bed fusion processes involve the spreading of the powder material over previous layers. A hopper or a reservoir below or aside the bed provides fresh material supply, and then the laser beam goes on top of each point, melting it and creating the solid metal. And now let's see the video so you also have a better understanding of this method too. As you can see, the laser beam goes point by point, melting the powder and creating the metal parts. And when this process finishes, then this reservoir goes on top and produces, let's say, creates a flat more space, the way you see it. One more layer of powder, so that the laser beam can come again and create the next layer of metal.
A really impressive technology.
Yes.
Actually.
Yes.
Of course, it's more advanced technology and more expensive, but it is really expensive and it's more for industrial use.
And it's also for high-end projects, like aerospace, for example, like space, because you can create amazing designs that are better than the traditional manufacturing methods in terms of properties. And I will show you guys in the end, you will see the Ultra car created here in Greece, which is more than 90% 3D printed using those types of methods. Which is right now, it's the fastest car in the world. Okay. Resharing, so I can make the video better this time. Now, what can we print with this method? The PBF method has a lot of applications, as you saw in the end of the video. You can do rapid prototyping for any types of parts. You can use it for commercial aerospace component, as I said. You can use it for medical implants, for example, a tooth, as you see in the picture. Automotive engines and components, and generally highly complex and delicate objects that you want to use in the industry, but also for consumer products. Okay. So what would you choose for our project? I think that I went ahead of myself and I actually answered this question. The answer, of course, is the FDM printer, because it seems to be the most suitable 3D printing technology you can use as a beginner. Because first of all, it's the cheapest one. The cost of 3D printers and the cost of the materials used are 2 times less than the next one, which is SLA. You can easily fail several times without worrying about the cost of the materials. And of course, there is a lot of choices of 3D printers that can be very cheap and or rather expensive, depending on what you need. The materials used for FDM 3D printing are also very cheap. A spool of PLA, for example, which is the most common material for 3D printing, costs approximately 20 euros. Also, FDM is clean to use. Let me show you here. So FDM is also clean to use. It's environmentally friendly, considering that the materials can be used. The PLA that I mentioned before is biodegradable, which means that you don't do harm to the environment.
Marco?
And yes.
We have a question from Christiana.
Okay.
Is it too more expensive SLA from FDM? It's asking.
No.
Is there a significant difference in the price of the materials or of the printer?
There is a significant difference in the materials, and most of you that have been in 3D printing or maybe knew how 3D printing technology worked in the previous years, the materials used for SLA printing were way more costly than the ones used in the FDM printing. For example, let's say that the same amount in 3D printing that you, let's say 1 kilogram of one spool, which is 1 kilogram of PLA, which costed 20 euros. In resin, it would cost 100 euros. Today, this has changed a little bit, which means that the resin, let's say, instead of 100 euros, you can find resin that costs 50 euros, for example. But still, it's more costly than FDM printing. But I wouldn't say that you cannot use SLA printing as a home printing method. The only problem here is that when you use SLA, is a little bit toxic, and you have to take some measures in order for you to not hurt your health. Okay, no problem. Thank you too. So let's also, since we started talking about some disadvantages, let's also talk about the disadvantage of FDM technology. The problem here is that we have poor details, as you can see on the previous slide here. Let me show you. Here you can see that SLA printing is much more accurate than the one at the FDM picture. So yes, if you want details, you choose SLA. But there are ways to change it, like smoothing, for example. We will talk about it in the next webinar. Now, the materials used for PLA, as I said, the first one and the most known is the PLA. The full name is polylactic acid, which is a thermoplastic polymer called bioplastic because it is derived from renewable resources like cornstarch and sugarcane. The next one is the ABS. ABS is a common thermoplastic polymer, typically used for injection molding applications, and it is popular due to its low production costs and ease with which the material is machined by plastic manufacturers. That's why, of course, they use it in molding applications. And the third one is a PETG, which is crafted from a mixture of polymers. It contains the same plastics which are utilized in order to manufacture plastic bottles. However, it's modified with the addition of extra glycol in order to make it a stronger material. So this filament is ideal for 3D printing because it offers all the advantages of ABS, like strength, heat resistance, durability, but has the dependability of PLA, which is known to be easy to print. The problem here is that we need high printing temperatures. It's very sticky, and it's not for support structures, which makes it hard to print for 3D printing because we need supports, but not impossible, of course. So these are some pictures of how a PLA biodegrades day by day. There's not much to talk here. As you can see, after 1 month, it already degrades, and in less than 3 months, there is nothing here. That's why most people use PLA. And of course, because it doesn't cost much. Now, except from the classic PLA and PETG filaments that you saw before, which is basically plastic, like the plastic bottles you use when you drink, you can find in the market flexible filaments. These flexible filaments, commonly referred to as TPE or TPU, are known for their elasticity, allowing the material to easily stretch and bend. As the name suggests, the material is elastic in nature, allowing the plastic to be stretched and flexed easily. For example, some filaments can be partially flexible, like a car tire, but others can be elastic or fully flexible, like a rubber band. Some other special filaments is the carbon fiber filament, which is not the same as the carbon fiber material. Maybe some of you know. They both consist of a continuous strand, but the filament is a combination of short carbon fiber strands and some printable material like the PLA, the ABS, and PETG. So it's, let's say, a combo of that. Another combo, let's say, of materials are the metal filaments, which most of them contain 80% more or less of real metal, so a lot of metal, which help us achieve this genuine look, as you can see on the bottom on those 3 parts. It's PLA based. So the other 20% is more or less PLA. And it is easy to polish and post-process. When the print is done, it looks like clay, like the one here, but then you can use some techniques to bring it with that metal gloss you can see here. You can use a rotary tumbler to finish the part, or you can use some fine grit or sandpaper and polish the print to the desired finish. So the better you polish, of course, the better the sign. And this elephant here is created from wood filament. Wood filaments contain typically 70% PLA and just 30% wooden fibers. But from texture to smell, everything feels very real. This means that wood 3D printed parts can actually be treated like real wood. The picture here that you can see, this is not the finished product. So we have to do the post-processing with a sandpaper in order to actually see, let's say, the sign of the wood. Of course, all those special filaments are not used just for the aesthetic purposes. For example, copper filament has antibacterial properties and antibacterial action has been scientifically validated that it eliminates more than 99% of fungi, viruses, bacteria, and a wide range of microorganisms. This makes the copper filament a perfect choice to use when it comes to prosthetics. Now, in this slide, you can see a lot of types of filaments categorized to solid, flexible, and composite. In the solid category, you can see the classic ones that we mentioned first. In the flexible category, you can see filaments like the TPU and TPE. And in the composite material, you can see a combination of solid filaments with wood, metal, glass, and other stuff. This creates the composite filament, which have those interesting properties that we talked about. And as you can see, they are all placed based on their difficulty level. So as you can see, of course, we can start with a PLA or PET. Then a little bit harder to use are the flexible ones because they have other types of properties. They are even harder to use than, let's say, PLA with copper or bronze. So if you want to change from PLA, maybe choose a composite material and then go to the flexible ones, because the flexible ones are more like rubber. And as you may understand, it's hard to 3D print a solid rubber. Okay, so which material should we use with our FDM printer? Should we use PLA? Yes, because it's cheap, it's environmentally friendly. Let's not go all over it again. Should we use ABS? No, because it's not great for your health. You could do it, but the 3D printer has to be in an open space, not inside your house, preferably. Should we use carbon or copper material? Composite filament. We could, but for the first print, since we will fail for sure a lot of times, it's a pity to use such an expensive material. With wood, it stands the same, and also wood is not very pleasant to touch unless you process it, like carbon. And TPU, yes and no, depending on the use of the final object. So if you actually want your model to be flexible, this is your only choice. But if you don't, then this is not even a choice for you. I mean, I think everybody understands that. And the last one is PERT-G, which I wouldn't decide to use as a beginner because, as I told you, it's pretty hard to be printed. At least it's harder than BLA and ABS. So the best choice for a beginner is an FDM printer with a PLA material. Try to change my mind.
Okay, Marco,
Yes.
maybe now it's a good time to have a break. And first of all, I want to ask the participants if they have any questions for you.
Of course.
Do you want to ask something about the technologies of the 3D printing that Marcos presented to you, or maybe about the materials, their properties? You can also write in the chat.
Yeah, one question for temperature about printing PLA and ABS.
Mm-hmm.
What is the recommended temperature, or maybe models is small and bigger, the temperature is one, and
Okay, Rado, let me try to answer that, and if I don't cover you will ask again. So basically, the recommended temperature depends on the manufacturer. Most probably for PLA, the recommended printing temperature is from 200 to 210 Celsius. And for ABS, I'm not sure, but it's more than that. But always there is not a standard here. You should always check what each manufacturer says that it's the best temperature to print. Two spools of PLA that are created from a different manufacturer work in another way, and they behave differently. So if you use, for example, 200 Celsius for both of them, maybe for one of them it's perfect, and for the other one you maybe fail, your print will fail. So each time you have to check that.
okay, thanks. I print 200 degree and everything is okay. My project is small and the quality is good for this beginner printer. Everything works.
Okay. Okay. Perfect. Perfect.
Okay, thank you. Another question: which country does most 3D printing currently, and for what purpose?
Good question. I don't know. I don't know. That's a great question, and I think you can find information on the internet for sure. I think I saw some types of videos regarding that. Maybe Thano, do you have any info inside?
No, I don't have such statistics. We can search in the internet.
I think that there is a country that uses a huge amount of 3D printing. I'm not sure. In Europe, Switzerland, I think. I'm not sure. But yes, that's a great question. I don't know.
Okay. So, okay. First of all, I want to remind you to change your name if you haven't written your full name, or if you have used a nickname. Moreover, if we have participants in this webinar that they haven't been registered in our form, then I will upload right now in the chat the link for the registration form in order to be registered, because it is also important for us to collect some statistics about the profile of all participants. And moreover, it is it would be very easy to inform you about the upcoming webinars. And finally, I would like to ask you, what do you prefer? Do you prefer to have a break, or maybe we can skip the break and finish 20 minutes earlier? What do you think?
For us to skip the break, but I told you that.
Also, we were discussing that with my colleague Julie from Naval Greece, that okay, perhaps it is better if we skip the break, but we would like to have a feedback from you. Better skip. Okay, so if you don't feel too tired, let's continue with the presentation.
Well, in the chat is
okay.
skip.
Skip.
Everybody
Okay.
says skip.
Okay.
Okay.
Okay. So
And maybe we can ask
continue.
you that at the beginning of the webinars every time, so we know what you feel about it.
This is an important information for us. I think that we can do that also for the rest of the webinars. It's better to do it instead of 2 hours, maybe 1 hour and a half without a break. It would be more convenient, I believe, for all of you and for us.
I think that the best thing to do here, so everybody can relax, let's say, for a little bit, is to pause 1 or 2 times for some questions for 1 or 2 or 5 minutes, and then continue.
Okay.
Let me also answer to the question about the countries, because it was an interesting question, and I instantly tried to find some answers in the in Google. So, of course, USA is #1 right now, and then we have China and Germany. So basically, the most industrial countries are also the ones that use 3D printing the most, which makes sense.
Okay, before we continue, I would like to ask you a favor, of course, if you like, and for those that they want to. Do you have a problem to switch on your camera and have a screenshot? Just for our social media, it would be nice to have some faces in the panel. But of course, if you would like, you can do that. It's not an obligation for you.
Maybe in the end. So
okay, maybe you can prepare yourself
right
for the end of this webinar to switch on your camera and have a screenshot with all of us. Okay. So you will have time to be prepared. So if you don't have any question, we can continue with the presentation.
Okay. Let's start.
Let's go.
Okay. So we move to the applications and the future of 3D printing. Here, as I told you, no, I actually didn't tell you that. 3D printing is a relatively new technology, which evolves rapidly in the last decade. So here I try to categorize the majority of the applications of 3D printing. The first category I want to talk about is the print on demand category, which is pretty self-explanatory. This category includes companies that basically print whatever a customer would ask them to print. And of course, a customer would refer to as such a company in order to create a prototype or a product, a specific part that cannot be produced through molds, or you cannot actually find it easily in the market. The second category we are going to talk about is 3D printing machines. As you may understand, a huge part of 3D printing field are the machines themselves. Right now, huge amount of research is being done in order to create better, faster, and more economic printing machines. 3D printing technology is not mature yet, which means that the research behind 3D printing is also relatively small up to this point. The third category is the new technologies. And what I mean by new technologies is, let's say, the future of 3D printing, like printing food, human tissue, better metal parts, faster 3D printing technologies, and all that good stuff. And lastly, I would like to talk a little bit about 3D printing in architecture, because it's really revolutionary to see a 3D printer actually print a whole building from 0 to 100% with the minimal use of human manual work. So, print on demand. Now, these are three interesting initiatives regarding the print on demand category. The first one is Mobile Smart Factory. And what this company does is basically bring the whole 3D printing manufacturing installation in front of your door. As you can see on the upper left, they actually bring the containers at the facility that they are going to print the part. After the slide, I'm going to show you a small video so you can understand better what I'm talking about. The second one is ShapeShift 3D. This initiative is consumer-based, which means that even me and you can ask for a 3D printing model and have it delivered to our house. The company focuses on designing the next generation type of products like shoes, bracelets, generally things for everyday use. But the difference here is that those products are customized based on your shape. That's why they use 3D scanning in order for you, to example, to scan your feet and create a shoe that fits perfectly on your feet, for example. And the last one here is Fictive, which is a company that creates custom tools with high accuracy for professional use. And it's a classic online platform where everybody can log in and ask for a quote. And if both ends agree, then Fictive starts printing the product while you can also track the progress of your product. Now I will stop sharing because we will show those videos and reshare. I'm really sorry for the inconvenience, guys, but this is the best for you, not for me. Okay.
The Mobile Smart Factory is a modular container factory that ensures flexible and reliable production capacities wherever needed. The system consists of 2 containers, one operating and one production unit, and is equipped with cutting-edge 3D printing devices. It enables a cost-efficient and fast supply of metal and plastic parts by covering the entire additive manufacturing process, including pre- and post-processing. The control unit consists of a PC workstation, industrial polymer printer, scanning system, and storage area. The on-demand production starts with a digitized component using a CAD software. The available scanner allows for a fast and simple creation of digital files if no CAD data is available. All parts identified in a parts screening process during the customizing process of the Mobile Smart.
So here, if you didn't understand, guys, inside this container, you have the 3D scanner, the 3D printer, professional 3D printing, the PC that you use the 3D printer, and you just need one person to handle all that stuff.
Factory are stored virtually in a component database. This avoids excess inventory and guarantees an efficient production. Once the data preparation phase is completed, the data is transmitted to the 3D printing unit. Next, the production materials needed for the 3D printing process are selected from the storage area in the control unit. This includes wire reels, building platforms, and various tools. The 3D printing system is the heart of the production unit and customized based on your individual needs. For the printing of metal parts, we use a multi-optional 6-axis machining center that combines wire arc additive manufacturing with milling and drilling in one clamping position. After starting the printing job manually, no more supervision is needed. The machine measures the building panel and starts the 3D printing of your component through a layer-by-layer application on the building platform. The built-up part is then finally machined by CNC milling. If needed and compatible, pressing tools are installed to smooth out the surface roughness of the component. A final tactile measurement ensures the provision of functional end-use parts. In case of a spare part repair, the machine scans the component before printing. At the end of the production process, the final part is measured again to ensure the correct dimensions. The operator can now safely remove the component from the machine. After the visual check, the part is ready for usage. Mobile Smart Factory, your modular and independent factory in a box for a flexible and reliable additive.
So that's a Mobile Smart Factory, and this is ShapeShift 3D.
Say goodbye to small, medium, large, and say hello to Custom Fit. ShapeShift 3D is a new kind of solution for e-commerce and retailers, accelerating and facilitating the production of personalized wearables by introducing a new and scalable custom fit process that seamlessly integrates into businesses from the online customer checkout all the way to the manufacturing. ShapeShift 3D coined this entirely digital and automated customization process as Scan, Fit, Print. Scanning can be done right from your home with the help of a 3D scan app. With a click of a button, customers can send their scan to the ShapeShift 3D cloud servers for custom fitting. ShapeShift 3D's unique customization technology automatically and instantly fits the product to the customer scan while respecting all medical, design, and product norms, making it ideal for medically approved wearables. The custom-fitted product is then automatically sent to the designated facility for manufacturing and assembly. With a new, scalable solution, the possibilities are endless. Shifting toward custom fit means offering a better quality of life for your customers. ShapeShift 3D. The future is custom.
Okay. So as you can see, both of those initiatives look a lot futuristic, because right now we go to Zara and we check our our size, and then we decide what to buy. But looking to the future, this is the next step. Maybe you will scan your chest and instantly you will know what to buy from the internet, for example. All right, now let's move to 3D printing machines. The first one I would like to use to talk about is the One Click Metal company, which uses laser powder bed infusion technology, the one that we talked about, the professional one with metal, where metal is created through powder, as we said, with the use of laser beams. The innovation here is that this specific machine is relatively cheaper than those machines out there. It has a huge robustness, and the whole machine, as you can see on the upper left, is pretty small. Generally, 3D printing of metal parts costs a lot of money and require a big amount of space, but this company tries to change that. So guys, this is not something special, but it's a move to the next step of 3D printing. The next one is Glowforge, which is another interesting initiative. where a machine does a lot of things with one type of hardware. This machine can do woodworking, laser engraving, laser cutting, and create consumer products, a huge variety of consumer products, while it can also assist the manufacturing processes. So one machine for all those things. The last one is Azul 3D, and this is an interesting one. This uses HARP technology, the predecessor of which is the SLA technology. So it's, let's say, a more special type of SLA technology. And with the use of HARP technology, Azul 3D achieved to be 100 times faster than the other commercial printers, which makes it available for mass production of products. So here you can see an initiative that tries to compete with other types of manufacturing, like the subtractive manufacturing, and it actually is faster than those. Okay, one more video of One Click Metal. I added that so you can have a better idea of how the metal printing works and how this can actually be commercial. And the small business can buy this type of stuff and start actually printing metal. He exports the parts and moves them to the next station where he cures them. And this is the final part. Okay, next one, architecture. As I've already mentioned, I've added some architecture initiatives in the webinar in order to show you guys where 3D printing stands when it comes to architecture. First initiative I would like to mention is MyCope, which 3D prints building with the use of concrete by printing the building layer by layer vertically and then rotating the building, as you can see here on the lower left picture. And then second one is Madbots, which uses the same technology, but instead of creating the building vertically, they print it on the spot horizontally. Let's move to the next slide where you can see Madbots create the building from zero. So as you can see, the 3D printer here is huge. It should actually be bigger than the house it prints. And it works like an FDM printer. The same philosophy like the FDM printer. The only difference is that instead of PLA, here we use concrete. And instead of a small printer that will cost 200 euros, you buy a printer larger than your house. So if you want to try architectural 3D printing, make sure you have some space left on your backyard. And now to the good stuff, the new technologies. Those are the technologies that we're going to see in the future, guys. So the first one I would like to mention is Zolo. Zolo uses volumetric 3D printing technology, which is a technology that creates the whole part simultaneously. This is the fastest 3D printing method technology discovered yet. And since I can't describe it enough for you to understand this, I also don't know exactly how volumetric technology works. We will see a video after that to help you understand how this technology works. But generally, it's the fastest way to 3D print something right now. The second one is Mantle. Mantle is an initiative that introduces TrueShape. That's a process, and TrueShape is how they call it, which combines the rough part precision and finishing processes all together with the use of a new type of metal powder. This way, Mantle can create metal parts much faster than the traditional way that you saw before, for example, one-click metal, or generally the industrial metal printing. Lastly, I would like to mention the organic 3D printing, which is a revolutionary field of research right now, expanding rapidly. Because this is not just about better products, guys, and easier way to create products. This is also about creating sustainable foods, creating actual human organs to save lives. Unfortunately, since this field is not yet on a commercial level, I could not find a lot of things to show you, but I encourage you to research it by yourself, because there is a lot of interesting information about this topic on the internet. And in my opinion, we will see amazing things in the field in the following years. But I have found a video about Zolo and Mantle. So let's see those two. They're pretty interesting.
Just using rays of light, this new 3D printer sculpts objects all at once, making it one of the first designs of its kind. This latest method, coming from UC Berkeley and Lawrence Livermore National Lab, is called computed axial lithography, or CAL for short. It uses a newer technique called volumetric printing.
Volumetric printing is a category of additive manufacturing where all points inside a 3D object are materialized or created pretty much simultaneously, as opposed to building up the geometry layer by layer, which is how virtually every other existing additive manufacturing process works today.
So CAL is printing smooth, complex geometries like those found in the statue The Thinker. There are no symmetrical sides and no hard staircase-looking edges, which is totally novel. Another promising feature of this device is called overprinting, which is when they can take objects and print around them, like taking the metal component of a screwdriver and printing the handle. This is a technique that our additive manufacturing printers today have trouble accomplishing. You see, even other liquid printers, like those that use stereolithography, are not considered volumetric. Although stereolithography printers also use a bath of resin, they're still printing objects layer by layer, slowly pulling the object out and selectively curing sections with a light in a process called photopolymerization. Researchers for CAL eliminated this long process, since CAL can print within minutes and is special since it can print all at once too, and it's still a very new technology.
Computed axial lithography, the merging of the relative rotation to build up a 3D intensity dose with fabrication. This is the first demonstration of that approach.
By By just using rays
Oh,
of
sorry.
light, this
Okay, so this was Zolo, and hopefully we will see this technology in the upcoming years. And this is Mantle.
Mantle's TrueShape process prints, shapes, and sinters precision parts from a CAD file in a fraction of the time and cost of conventional manufacturing. Conventional precision part manufacturing is a 12-step process that takes months. Existing 3D metal printing technologies only address a small portion of the process and require costly, time-consuming post-processing. Mantle eliminates these steps and produces precision parts by combining both rough part creation and precision finishing into a single hybrid process called TrueShape. The process starts with Mantle's line of patented flowable metal pastes, or FMPs. Metal particles are suspended in a liquid carrier to ensure safe handling and uniform particle distribution. FMP materials contain multiple different particle types and sizes to custom tailor the density, strength, and surface finish of the resulting metal part. At its core, TrueShape is an extrusion process. Using a precise positioning system, paste is deposited one layer at a time. Once an entire layer has been printed, it is heated to remove the liquid components of the paste, settling the metal particles into a dry, dense compact, which is held together by a small amount of binder. After a number of layers are printed, high-speed cutting tools automatically refine the shape and surface finish of the printed layers. Because the dried FMP material is not yet fused, the shape refinement process is up to 50 times faster than conventional solid metal cutting. The steps are repeated to build and precision finish the entire part. The part is then transferred to Mantle's high-temperature furnace, where it is heated to over 1300 degrees Celsius and is sintered into a solid metal part. From the sintering process emerges a precision part with unmatched surface finish, detail, and tolerances that can be placed into production with little or no post-processing. Precision part creation that used to take weeks or months now takes just days with TrueShape technology from Mantle.
So the interesting thing here is that Mantle actually uses FDM technology, as you can see here. They are using the FDM technology, but what they deliver is this interesting type of material that is imported through the, I don't know if it's a spool or a powder. So it's delivered through the nozzle, and it actually creates this very interesting synthetic metallic part, which, as they claim, can be actually used in more advanced applications. Oh, sorry about that. Well, actually, I should have done it earlier. So let me share the screen without my video clip here so you can see better. Okay. Once again, this is just for you guys, not for me. I have to pass all those. Okay. So, some last things before we close. In order for you to have a general look of what's going on in 3D printing and the market size of 3D printing. As you can see, the biggest use of 3D printing is utilized in the automotive industry. This is due to the incredible properties achieved by metal composites and the unique design of such components inside the car or a motorcycle. But of course, we are not talking here about mass production. Of course, we are talking about luxury cars and vehicles, because as we said, 3D printing is more for custom products. If we want mass production, it's better to use the conventional type of manufacturing processes. Now, one example, some of you may know the Chaos car. It came up, I think, this year, or maybe at the end of the previous year, I'm not sure. It's created here in Greece by Spiros Panopoulos. Chaos is an ultra car, and it's said to be the fastest car in the world right now. This car, guys, is more than 99% 3D printing. Sorry, more than 90% 3D printing. We will see a picture of that in the next slide. The second field, the red one, is the consumer products, from useful objects like clips and tools to cosplay stuff like a 3D printing sword, or something, let's say, I don't know, what can you think about? Iron Man's helmet, for example, whatever. And the other three fields are healthcare, aerospace, and industrial field, which, as you can see, are also close together. They have the same percentages regarding the market share. What's more interesting here, though, is the KRG. KRG stands for Compound Annual Growth Rate. And as you can see, those are close to 40% for every field. This is the annual growth. This is the growth each year, guys. This means that every 2 to 3 years, 3D printing market share, and therefore the market opportunities, the companies, the jobs, all of that stuff, they are double the size. So if we move to the next one, you can actually see it better. Here we can see some. So let's say all of those fields. As you can see, the market size of 3D printing in 2013 was $4.4 billion. 3 years after, it got double, $8.5 billion. And at 19, it got quadruple. And now the market size is estimated to be close to $21 billion. And of course, the future predictions estimate the corresponding type of growth, basically predicting the same as the one here. And some 3D printing business ideas for you guys. I have decided to gather some ideas. So first of all, you can, of course, you can create business to client products, like, for example, customized earbuds, or maybe an ergonomic mouse or a keyboard, whatever you can imagine. An interesting field to create 3D printing, 3D things is in education. For example, as you can see on the upper right picture, this is a 3D map of a city. And this is very useful for children with visual impairment in order to understand how a map works and how to navigate. But I guess most of you had thought of that type of products. So what you didn't think of is that your company may also work exclusively business to business. You can improve existing products or machines, create promotional products, or detailed models of a part inside the car. On the bottom picture here, as I promised, you can see the Chaos car we talked about before. And as I said, this car is more than 99% 3D printing. Some more business ideas. Another field which is huge, as you saw on the market size, is the medical industry. If you're close to that field, you may know that you can create organic 3D printed pills like those here. Moreover, 3D printing is great here since you can design unique and personalized medical implants and prosthetics. But 3D printing is also great in rapid prototyping. Basically, it's rapid prototyping. Rapid prototyping is an umbrella term. It refers to a group of techniques used to quickly create a model or an assembly using CAD data. As you may understand, 3D printing is the easiest way to translate this data into an actual physical model. 3D printing is also great for creating PCBs and chipsets. You may see this picture. As you know, it is almost impossible for a human hand to create those small synapses for a chipset inside a mobile phone, for example. So you can do that easily with 3D printing. Sorry for that, but I'm moving fast because I see that a lot of time has passed. So again, one other field is a manufacturing field. Of course, you saw on the videos a lot of applications. You can create custom-made tools that you can find in the market, and of course, parts. And last but not least, fashion and art. And of course, here we can design and create whatever you can imagine, from earrings to metal rings to cosplay items, as we said, the helmet of Iron Man, interesting shoe designs, custom classes, and generally art, whatever type of art you can think of. And that's an interesting topic. Art is a very interesting topic, since maybe I will ask you in the end, but I haven't saw a lot of things 3D printed regarding art. Anyway, and this is a success story, guys. This is Claire Cabot. And she discovered that 80% of women do not wear a bra adapted to their chest, which resulted in bad posture, bad blood flow, and for a lot of women it was inconvenient to wear. That's why she created Shape, which is a bra, basically, enhanced with a 3D printing underwire, which is adapted to the individual morphology of each woman. Now, anyone can 3D scan their chest and have a bra designed specially on the shape of their bodies. Now, why did I specifically choose Claire? Did she actually change the world? No. But she introduced another way to make life better for some people. And in my opinion, this is the meaning of social entrepreneurship: solving problems in order to make life better for the others and the following generations. So that was it, guys. I was Marcos, and we will be together in the next 2 webinars. Hopefully you liked this one. Hopefully the next 2 webinars will be even better. And yes, this was the introduction to 3D printing. So should we ask for
any question?
For them to write.
First of all,
better stay here.
Let me thank you for the great presentation. I really like it. I really liked the applications, the last part of your presentation. It was really interesting, and you gave us some fantastic examples. Guys, if you have any question for Marco, please, now is the time.
Marcos, I just want to say thank you. It was really very interesting, and the examples in the end for us, for our team, were very, very interesting. I didn't have in mind that we could use 3D printers for such things.
That was the point. That was the point. Thank you, Maya.
Any other questions? Maybe, Marco, maybe you can stop sharing your screen.
Yes, yes, good idea. Okay.
Okay, any question about any application, any material?
Excuse me, may I say something about the application?
Yes, of course.
Yes, thank you very much, because you said the art, sorry about this interruption, but can you see this? It's
miniatures.
Miniatures, yes, I used a lot of miniatures, 3D printed miniatures, and it's very great application because they are probably for up to 10 times cheaper than the industrial ones. So that's a huge application. And I know about 3D printing in this sphere of participation of 3D printing in my hobby. Thank you. Just this one.
Thank you, Netko. That's actually true. A lot of people, let me add on this, that a lot of people use the SLA technology since it has a great accuracy to actually print miniatures and work as freelancers, paint those miniatures and sell them to the public. And actually, most of them make a lot of money. Just saying.
Yes, it's a good example because we are talking for young entrepreneurs.
Yes, exactly.
Excuse me, once again, I will interrupt because they create these monthly subscribe platforms, and monthly subscription is from $10 up to $25 per month. And some of the organizations, I don't know if it's just one man or a lot of people engage in this. They have over 10,000 subscribers. That's 10,000 subscribers.
That's huge.
That's huge.
Yeah, that's huge. Yeah.
Thank you.
No, thank you, Netko. Can you write down in the chat which initiative this is? I would like to check that out actually. Thank you. Anyone else? Any questions? Anything you want to say? We lost Thanos, I think.
Can you hear me?
Okay, you're here.
Yes,
you're here.
Okay.
I can see you.
I can hear you, but there's a problem with my camera. I don't know what happened. So obviously you can't see me, but you can hear me.
Okay, perfect.
Yes, could you tell us, we have a question, could you tell us what to expect in the next webinar? Okay, just to give you a short briefing about all the webinars, we will have in total 6 webinars until the summer, until the end of June. The first 3 webinars, we will presenting 3D printing basic principles, how to slice and use software for 3D printing, and types and hardware of 3D printers. And then the next 3 webinars will be about 3D design. We will present you, Open Europe will present you the design software Blender. And after the summer, we will have the training, 6 more webinars about entrepreneurial skills, a basic and advanced training about how to become a successful entrepreneur.
So for the, Thanos, you want to continue?
Just to say that you can always find the agenda of the webinars in the site of the project. I have uploaded the site, the link in at the beginning in the chat. Enterproject.eu.
Okay, so what I would like to say for the upcoming ones, the ones that are close, the next two, as I said, are I will be your tutor on those webinars. And to make a fast resume, what we will do in the next one, we will talk about the hardware of an FDM printer. So those of you who actually have an FDM printer, it's going to be interesting, but also the other ones who don't have may understand a lot of things. And we're going to talk a little bit about the actual process of printing a model from zero to the end. And in the third webinar, I'm going to actually use a slicer. So you will see me changing some properties, changing some temperatures in order to make the printing process better for the printer and export a G code.
Okay, thank you, Marco. Okay, see you in the next webinar. So if you don't have any other question, that's all we've got for today. Thank you for joining us and submitting at the end your questions. If you have any other question or you would like to speak to us further, you can send us a mail with your question. Have in mind that we will upload the full recording of the webinar in our website, but we will inform you, as this is the first webinar, we will inform you with a mail when this recording will be ready. And we hope to see you soon on the next webinar.
Thanos,
Yes.
will we make them open their cameras?
Yes, maybe. Okay, of course, I can't right now open my camera. I don't know what happened but to my computer. I really don't know. So for the rest of you, anyone that would like to open the camera, it would be nice to have a screenshot from all of you. That's great.
Okay,
Thanos,
more and more.
I didn't check the chat thoroughly, but did we upload the evaluation form? Do you want to do?
Okay, I will do that. I will do that. I have uploaded the script.
Thanos, I have it already. May I upload it?
Yes, yes, yes. You can do it.
Okay. I'm taking the print screen, guys. Smile.
Smile. I will smile too, but you can't see me.
Perfect. Thank you all.
Thank you all. Julie, just upload the evaluation form for this webinar. It's very simple. I think it's just 6-7 questions about the quality of this webinar. We kindly ask you to fill this form. Thank you another one time for attending this webinar. Hope to see you soon. Bye-bye.
Thank you all, guys.
Bye, everyone.
Thank you.
Bye,
Have
bye.
a nice day or evening. Bye.
Bye.
Bye.